afternoon and welcome back to our session of Urban Agriculture online training for SEA Creative Camp. And so for today, we will have our second meeting on the urban agricultures, and today we will have the Mutinlupa National High School, which will talk about the aquaculture techniques. Okay, so without further ado, please Mutinlupa, you can start your presentation.
Good afternoon. We are from Mutinlupa National High School, Philippines, and we'll be presenting to you aquaculture. Oh, it's not moving. Please. Sorry, we're having a technical difficulty.
Okay na, technical difficulty. Kung na-try ko na ito. Go.
What is aquaculture? Aquaculture is the controlled production of organisms that normally live in water for a better yield and economic viability. Aquaculture is producing fish in limited and controlled environments such as ponds, tanks, or aquariums, lakes, etc. It is a human intervention to increase aquatic productivity through cultivation activities.
This is according to UNIATI 2018, and it also says that it multiplies the population and growth of biomass and improves the quality of aquatic biota products to obtain profits.
So aquaculture has the following benefits. So it can contribute in the food production, stock enhancement, fish for recreation, ornamental fish production, and industry material production. To UNIATI 2018, here are the factors to consider for a good aquaculture practices. It should have a good site location, pond preparation, fish stocking, feeding management, and water quality.
For site location, what do you need to focus on? The first one is the water resources. To supply aquaculture operations, it's typically surface water or groundwater.
Next is the source of water free of contamination from fertilizers, manure, pesticides, or other chemicals.
And testing the water quality. Aquaculture sites. Examples. We have the ponds, wherein we can see the artificial or man-made ponds.
Have the lakes.
And tanks. And of course, we also have a photobioreactor here as included in the tanks. But if I may ask you, what do you think is the difference between a pond and a tank? If you will look at it, a pond can be natural or man-made. And an aquarium is an example of a tank, as you can see here, as well as photobioreactors. Now let's proceed to fish stocking.
How are you going to choose the fish? So you need to consider that to choose the fish with the same average size. Also, you need to give emphasis to the number of days of the fish. The fish it should be physically good, healthy and lively, have a good growth performance, and the time of stocking should be early in the morning or late in the afternoon, and should be adapted or can adapt to the environment it should live in. So you need to check for the quality of the fish. It should have a certificate of production free from any disease and should undergo stress test. So we need also to take note of the following formula. To find for the total biomass, the total weight of the stock in kilogram within the culture system. The formula should be number of fish times the average weight in kilograms. And to find the stocking density, the formula is the total biomass in kilograms over the pond area times the volume. We also have other formulas that you should take note in finding the number of fish needed to place in the culture rearing unit when you are given the initial stocking density.
Formula, initial stocking density in kilogram per square meters or cubic meters times volume or surface area of rearing unit. And that's the average weight of the fish in kilograms.
To find the number of fish required when given final stocking density in kilogram per cubic meter squared or cubic meter and survival rate known.
The formula, final stocking density times volume of culture system over or divided by the average weight at harvest times percentage of survival.
And to find the volume needed in meter and cubic meter,
the formula, length times width times depth, and that's all in meters.
to find the final number of fish when given final stocking density, harvest weight, and rearing unit volume, the formula is
Final stocking density times volume of rearing unit over average weight of fish at harvest, and that's in kilograms.
to find the initial number of fish when given percentage survival and the final number of
Fish.
fish, the formula is
Final number of fish divided by the percentage of survival. Next.
So these are the formula that you should take note in putting the fish on the particular environment that the fish should live in. So take note of the formula in order for you to have the good production and the good output of the fish that will be harvested from the pond.
The next slide is still loading.
Okay. Slide. Management. The number of days is written on the left side. You have 3 to 50 left side. You also have the feed amount in percentage from biomass. 3 to 5 days, you have 5%. 15 to 25 days, 4%. 25 to 45 days, 3%. 45 to 60 days, 2.5%. And 60 to harvest, 60 days to harvest, that is 1.5%. The protein used should be 28 to 30%.
And take note to buy feed from reputable feed supplier. And fish feed can be utilized within about 3 months to help maintain feed quality and safety. Water quality.
The
parameters are dissolved oxygen. The optimum concentration should be greater than 4.0 milligrams per liter, and it should be monitored twice daily. For the pH, it should be greater than 6.5 to 8.5, and it should be monitored twice weekly. For the ammonia content, you have less than 0.15 milligrams per liter. That's the optimum concentration and should be monitored twice weekly. For the temperature, the optimum concentration should be 27 to 30 degrees Celsius, and it should be monitored daily. The alkalinity of the water should be or should have the minimum of 0.50 milligrams per liter to 100 to 400 milligrams per liter, and should be monitored several times a year.
Same
as the hardness, that should be monitored times a year. For the water management, water change should be weekly and should starve the fish 24 hours before the water change. And add probiotics.
As one of the aspects of aquaculture, let's discuss algaculture. What is algaculture, Johanna?
Algaeculture is a form of aquaculture involving the farming of species of algae. The majority of the algae that are intentionally cultivated fall into the category of microalgae, also referred to as phytoplankton, microphytes, or planktonic algae. Benefits of culturing green algae.
It can produce such as food, animals, soil fertilizer, medicine, cosmetics, and health supplements.
It can also be used as feedstock for biodiesel with a very high yields, biofuel yields.
And it can be used to purify wastewaters. Now, that it absorbs greenhouse gases, it reduces carbon dioxide, and releases oxygen.
It has a great flux tolerance and photosynthetic efficiency with limited nutrient requirement and flexible cultivation conditions.
That means when you have green algae harvest, you can generate lots of income, and it is limitless depending on the size of the photobioreactor that you will design.
Algae cultivation can be done in a variety of environments, including open ponds, closed ponds, and photobioreactor. For the open ponds,
Can be categorized into natural waters, lakes, lagoons, ponds, and artificial ponds or containers.
for the closed ponds,
Cultivation systems that cost more than the open ponds and considerably less than photobioreactors for similar areas of operation.
and for the photobioreactor,
Closed equipments which provides a controlled environment and enables high productivity of algae.
An open pond system of algae cultivation. One of the most natural methods to culture algae is in a free environment, such as the open pond system. And considering the low maintenance and construction costs, open ponds are the best options for conducting initial experiments on a large scale.
open systems are categorized into natural or small ponds, lakes, lagoons, and artificial ponds, which are containers and
Lakes.
aquariums.
The most commonly known types of open pond system is the raceway pond. A raceway pond is a shallow artificial pond used in the cultivation of algae. The pond is divided into rectangular grid, and each rectangle containing one channel in the shape of an oval like an automotive raceway circuit. Each rectangle contains a paddle wheel, as you can see in the picture, to make the water flow continuously around the circuit. Next type of open pond system is the circular pond.
Here's an example of a circular pond. This is in Hainan, China, and in Japan.
So what to consider when designing an open system?
First is the mixing patterns. It plays an important role in the distribution of sunlight and other essential nutrients. Another one, mixing technology.
Mixing can be achieved using different technologies. For example, gas sparging and magnetic beads have been used in algae ponds.
And the depth of open ponds wherein we have a range from 5 to 100 centimeters. Let's proceed to closed systems. Here's an example of a closed loop system under the closed system or closed ponds.
Those systems are not exposed to open air.
And you should avoid the problem of contamination in culturing algae. That's why we create closed systems so that other organisms may not be blown by the air. Also, widespread mass production of algae by using this method for biofuel production. It's also a highly controlled production, the closed system as compared to the open system.
It allows integration facility with other facilities like combined heat and power and power system. The most popular method in closed-loop system is photobioreactors.
Of a photobioreactor. As seen in the picture, we have the tubular photobioreactors, and we also have the Christmas tree type photobioreactor, plate photobioreactor, horizontal photobioreactor, and foil photobioreactor. You can be creative in designing photobioreactors. Just make sure that you know the necessary parts or the integral components of your designed photobioreactor.
In conducting a closed system, you should consider the following physical parameters. First is the temperature, which an intermediate value of 18 to 20 degrees Celsius is most often employed. Next is the light. Artificial lighting by fluorescent bulbs is often employed for culture maintenance and experimental purposes. And lastly is mixed. In the ocean cell, air, plankton,
Hello, I'm sorry, but we cannot hear your voice. Hello? Hello? Still no sound?
Mm-hmm.
Yeah, okay, we can hear you.
Hello.
Hello, yes, we can hear you now.
Yes?
Yeah, okay. Okay, please continue.
Is it only from this slide that you did not hear us?
From last slide. One slide before this one.
Yes.
This one?
Yes, this one. Okay.
Okay, now we will share to you the best practices that we have at Mutinlupa National High School. And the first one is our Aquaponics Project, wherein we have the large-scale aquaponics with using ponds and PVC pipes. And we also have our small-scale aquaponics, wherein we improvised it using PET bottles or polyethylene bottles, and we designed frames for the aquaponics system. And each classroom has had this small-scale aquaponics or the improvised design for the aquaponics system. Number one is the bigger or the larger scale of our aquaponics, wherein we culture tilapia and different vegetables in our aquaponics system. Another project is a fish pond, wherein we also have the floating garden, where styrofoam are floating in front, on top of the fish pond, and there are also fish inside the pond itself. The styrofoam or the floaters also contain PET bottles with the vegetables that have been planted in it. So we also incorporate the hydroponics in our floating garden, wherein the plants are in those containers floating around our fish pond. But sorry, we were not able to take a picture just this morning. But here is the outer view of our fish pond. This that we have. And here we culture algae, which is the green algae, the Chlorella vulgaris, and it's very efficient in cultivating the Chlorella vulgaris. Now, to discuss to you the parts What do you think, Johanna, must be included in our bioreactor so that you will effectively cultivate the algae?
Okay. Uh, First, you should have the agitator. Agitator has motor, shaft, and impeller, which is needed in the mixing process. And next is the blue UV LED lights, which will serve as an alternative source of sunlight. And the third one is the sparger, which is connected to the air pump, which is used to supply gas to the algae. And the last one is the baffles, which is made up of glass that helps to induce mixing.
There you have it. As we said a while ago, you can be creative in designing your own photobioreactor. It could be in a large-scale design or just a simple one like this one. And it's highly portable. Now, do you have any question? Thank you for listening. Have a nice day.
Okay, thank you, Mutinlupa. And does anyone have a question for Mutinlupa?
I-off mo.
Okay, so my question is, in the aquaponics system in the big pond, you use the tilapia fish, right? But what about the small one from the gallon?
For the gallon?
Yes?
Also.
Hello, Mutinlupa? We cannot hear any sound from here. Perhaps you can turn off your video sharing. Yeah. Still no sound.
Okay, hello.
Hello, hello. Yeah, we can hear you now.
Are there still questions?
Yes? I'm sorry?
Do you still have questions? Did you hear our answer to your first question?
No, sorry.
Oh, sorry, you did not hear the answer.
Yeah.
We have two types of aquaponics in our school. We have the larger one, which is the pond, and the smaller one, which is the improvised aquaponics system, can be found in the classrooms. So one classroom has that improvised aquaponics system, and they have the freedom, the students or that classroom has the freedom to choose what fish they would like to culture. And it's not necessarily for food. Some of them choose to use ornamental fish such as goldfish, guppies, or fighting fish. But some prefer to still use tilapia, so they buy tilapia fingerlings. But sometimes they transfer these to the larger ponds that we have in the school. So that's just for every classroom.
Okay, thank you. But is the aquaponics for the classroom works? I mean, what
Yes,
plants that you
the
grow there?
plants,
Yeah.
we grow medicinal plants such as gotocola or Centellia asiatica, and those systems are used primarily for researches also. So if they would like to use some medicinal plants for their researches, they culture them in the small-scale aquaponics inside that classroom. Because here in our school, we have the special science classes where they act as little scientists. So they usually create different researches. So whatever plants that they would like to culture, they just try it there. So there is no limit. We do not limit the students to whatever plant they would like to use in the aquaponic system. But of course, those plants that need sufficient amount of water because the system requires flood and drain process.
Okay. Okay. Thank you for your answers. Perhaps any questions from the participants? Please go ahead and type in chat. Mungkin bisa chat bahasa Indonesia and I will try to translate it.
Makamute pa.
Okay, perhaps another question from me regarding the green algae that you have successfully cultured, right? How ready is the industry to receive the algae, or perhaps how far have the Philippines or maybe any ASEAN country have uh, culture it in the large
Oh,
scale?
In our country, it is not yet widely spread or it's not yet really that commercialized. But there are some institutions that have already been converting the algae or the harvested algae
Ya, beri suara na, Iran.
biofuel. I hear something.
other countries are also cultivating green algae. So there are some countries in the Middle East that is already converting green algae to biodiesel. But here in the Southeast Asian countries, there are only a few who are in line with green algae. So that's why we are sharing this project to the Southeast Asian countries in order for us to help each other in dealing with the algae culture, in making it sustainable project or beneficial product in the near future.
Yes, because it's really a promising source of renewable energy. Actually, ExxonMobil Corporation, which is an American multinational oil and gas company, has this biofuel obtained from green algae. And maybe we can partner with them in the future and ask for assistance since uh, last time, this January, we were able to visit their booth in Abu Dhabi when we had the chance to go to the United Arab Emirates. And that's where we found out also that algae has already been widely used in those countries. So I hope, and we truly hope that in Southeast Asia, it will also spread and we can see the benefits that it really has to offer to all of us. And maybe we can work together to achieve that.
Okay, thank you. So in line with perhaps Simoy Biotrust program is that we are targeted to create some kind of infographics regarding the tropical biology, and I think this green algae can be a very interesting topic to be made into that infographics as to disseminate the information. So I hope we can work further
Yeah.
on that note. Okay.
We are very much open for any collaboration with the CIMEO and the Biotrop also. And with the benefit of green algae, it is surely the different efforts towards that will become beneficial. So if the Biotrop will require us to do the infographics, and we are very much willing to contribute.
Okay, great. Thank you, Mr. Jason. Sagale. Okay, we have one question from the participant. How to manage the fish feed remaining in the aquaponic? I mean the fish feed left over.
Sorry, we are hearing some unnecessary noises. We cannot hear the question clearly. I think there are some noises that
Okay, sorry.
out
Okay.
with the sound.
How can we manage?
How to manage the fish feed remaining in the aquaponic? The fish feed leftovers.
Fish feed.
How to manage the fish feed
Leftover
leftovers?
in the aquaponic system.
So in our aquaponic system, we are using feeds that are available in the market, but considering the amount of feeds that we apply on the fish or on the pond, it is just very minimal. So the consideration of having more or excess number of feeds is that's really a problem on our part.
And we are aware that when we feed the fish should be able to eat all of the food in around 5 minutes. And if the fish cannot eat all of the food that was put in the pond, we need to easily remove the leftover food. And we must also consider reducing the amount giving to the fish, given that we are giving to the fish. So we really need to choose feeding times. Yes, and of course, we choose quality food for our fish so that we will not have food waste or the feed waste. And we can also recycle these wastes into something useful. And we have been conducting researches on that as well. Yes.
Okay, thank you. Any more questions from the participants? Okay, I think there is no more question from the participants. So I guess you can close the presentation.
Okay, thank you very much.
Okay, thank you very much, Mutinlupa, for your interesting presentation. And thank you also to everyone who have joined this session. I hope you enjoy the session. So we will meet again at tomorrow, yeah, if I'm not mistaken. Yeah, we will meet again tomorrow to talk about the soil-based vegetable and fruit tree gardening, which will be delivered by SMP Saim Indonesia. So on that note, once again, thank you and have a great day, everyone.